they learn how tissue is prepared.
Oh, okay.
For them, by the way, it was fun.
Oh, fun, that's what it's fun?
Well, let me say this, if you don't have a passion for what you're doing, yeah, you're probably in the wrong field.
Shut up. I'm not gonna say I'm gonna go and cut the house and probably like cut it up.
All right. Where's the liver?
It's right under the.
That's
It felt so good to hold my
See,
nose.
I know.
know.
Yeah, I was asking a question, but as I put my foot right here, like the thing, the chair, like sinks. So I was in the middle.
My immune system works against me, I think.
Sinus.
All right. The liver sits in the right upper quadrant of the abdomen. It's surrounded by a connective tissue capsule made up of dense connective tissue. That dense connective tissue sends septa or trabeculi into the organ, which subdivides it into 4 lobes. Okay? So if we look at this liver, we're going to have a right lobe and a left lobe. Along the posterior aspect of the liver, sitting adjacent to the inferior vena cava, is the caudate lobe, C-A-U-D-A-T-E, caudate. And then anteriorly, there's a lobe here adjacent to the gallbladder called the quadrate lobe. Quadrate. So quadrate sits anteriorly adjacent to the gallbladder, caudate posterior, adjacent to the inferior vena cava, and then right and left are your largest lobes. The liver has 2 sources of blood supply. We've mentioned this before. The hepatic artery carries oxygenated blood into the liver. It's a branch of the celiac trunk. Okay. So if you look here at the base of the liver, the inferior surface, this red vessel is the hepatic artery. Now, you have another vessel right next to it that looks kind of purplish. Right. That's the portal vein. The portal vein is carrying in venous blood from the GI tract. So this is nutrient-rich blood, okay, but oxygen poor. So portal vein is carrying in venous blood that's rich in nutrients, whereas the hepatic artery is carrying in oxygen-rich blood. Okay. Now, at the same location where we see the hepatic artery entering and the portal vein entering, we see the common hepatic duct exiting the liver. And in fact, right here you can see it joined by the cystic duct to form what's going to become the common bile duct. Okay. This site, where all 3 of those tubular structures are either entering or exiting, is called the porta hepatis, which literally means the door of the liver. Okay, so this is where all the important structures are either entering or exiting. Now, what's going to happen is these 3 structures are being carried into the liver, surrounded by connective tissue from the capsule. And as this connective tissue subdivides the organ into lobes and then into lobules, these structures pass with that connective tissue and branch. So that branches enter into each lobe, and as that lobe is further subdivided into lobules, branches pass into each lobule of all 3 of these structures. So you have hepatic arterioles entering into lobules, and portal venules entering into lobules, which are subdivisions of the lobes. And then you have tiny branches of hepatic ducts doing the same thing. And so these lobules, which are the basic structural unit within the liver, are shaped a little bit like hexagons. Like this. Almost like a stop sign, except the stop sign might be an octagon. I don't know. Okay. And between each of these lobules, at the borders, you'll see connective tissue. Because remember, it's connective tissue that's subdividing the liver first into lobes and then into lobules. At the center of each of these lobules is going to be a structure called a central vein. Now, when you look at real tissue, it may not be perfectly centrally located. It depends on the cut. Along the periphery of the lobule, think of it at each point of the hexagon, you're going to see branches of those three structures that entered into the liver. You're going to see a branch of the hepatic artery, what we'll call an hepatic arteriole. You're going to see a branch of the portal vein, in other words, a portal venule. And you'll see a tiny bile ductule. Okay? That triad is called a portal triad. And you'll see a portal triad at each corner of the lobule. So you're going to see another one, for instance, right here. Okay? And you'll tend to see them kind of scattered along the periphery of the lobule. Now, let's go back to the central vein. Extending from the central vein toward the periphery of each lobule are columns of hepatocytes. Hepatocytes are the basic cellular structure of the liver. So these hepatocytes are large, irregularly shaped cells. They extend in a column toward the periphery, like the spokes of a wheel, if you will. And I could keep drawing, but the idea is that they're extending peripherally like this, all along the lobule. And then between columns of hepatocytes, you're going to have hepatic capillaries that extend from the periphery to the central vein. So for instance, you're going to have a type of capillary that's extending like this, carrying blood toward the central vein. And you'll see multiple structures like this carrying blood in toward the central vein. Now, these are not your typical continuous capillaries. These are dilated capillaries that have relatively large intercellular clefts. They're called sinusoidal capillaries. So sinusoidal capillaries are dilated capillaries that have that are more leaky, if you will. And so what we call these capillaries are hepatic sinusoids. Hepatic sinusoids. And so blood from the hepatic artery and blood from the portal venule is going to mix within the hepatic sinusoid. So that as the blood flows toward the central vein, that sinusoid is feeding the surrounding hepatocytes with both oxygen and nutrients. So the blood flow is moving from the periphery of the lobule toward the central vein. Now, at the same time that that's occurring, these hepatocytes are producing bile that's traveling in the opposite direction through tiny canaliculi toward the periphery. They empty into those little bile ductules. So bile is traveling in the opposite direction, through little biliary canaliculi toward the periphery of the lobule and emptying into these little bile ductules. Okay, let's talk about what happens to the blood in the central veins. The blood in the central veins is going to eventually enter into larger vessels called hepatic veins. And hepatic veins from each lobe are going to empty into the inferior vena cava just before the inferior vena cava passes through the diaphragm. So these central veins eventually anastomose into progressively larger vessels, forming hepatic veins. And the hepatic veins are going to empty into the inferior vena cava.
So you have 4 hepatic veins.
So you have, you have, let's say 4 hepatic veins, but it's variable. It's really not 4, but we'll say 4. And that's a good number. So if we look, for instance, at this lobule here, okay, here's that triad in each corner of the lobule. Okay, this is one of those hepatic sinusoids carrying blood toward the central vein. Okay, central veins are joined together to form larger vessels. In this case, they're called interlobular veins. Okay, which then join into or enter into hepatic veins, which then drain into the inferior vena cava. If you look at this magnified view here, there's a portal venule. That's it. Now, don't use this terminology here. I don't like this terminology. So instead of calling it a portal arteriole, call it an hepatic arteriole. You can call it a portal venule. And then we use the term, instead of bile duct, call it a bile ductule. That's a term used by a lot of texts to indicate it's a very small bile duct. Okay? But notice that the hepatic arteriole and portal venule empty into this hepatic sinusoid, which is carrying blood toward the central vein. Now, these sinusoids are lined not only by the endothelial cells that make up the sinusoids, but you also see scattered macrophages. In the liver, these fixed macrophages, just like in the lung, they have a special name. They're called Kupffer cells. K-U-P-F-F-E-R. So Kupffer cells are specialized macrophages present within the liver. This slide also demonstrates these very, very thin, tiny canaliculi passing between hepatocytes and draining into the bile ductules. Now, these bile ductules eventually anastomose, join together to form either the right or left hepatic duct, which in turn are going to form the common hepatic duct, which is going to be joined by the cystic duct to form the common bile duct. So remember the names of the different components of the biliary system. So most substances, not all substances, most substances taken in by the diet is broken down, and its components have to first pass through the liver before reaching the systemic circulation, before reaching the heart and the systemic circulation. So with respect to drugs that we take orally, those drugs are going to be absorbed into the mesenteric veins, and they're going to pass through the portal system into the liver. where they may be broken down, where they may be metabolized before they reach the systemic circulation. That's called the first pass effect. Drugs that are extensively metabolized by the liver sometimes have to be given by a different route. You can't give them orally if they're broken down before they reach the systemic circulation. So this business about the portal circulation carrying both endogenous and exogenous molecules first to the liver before reaching the systemic circulation can have clinical importance. All right. Let's talk about some of the roles of the liver. Number one, it produces bile. What is the purpose of bile? Bile is going to enter into the small intestine, and what it does is it emulsifies fat. It emulsifies fat. What in the world does that mean? Let's draw a picture again. Okay. Let's suppose you ate some Popeye's fried chicken. Okay? And you have a big old globule of fat within the stomach. That big old fat globule doesn't mix well with the gastric juice because the gastric juice is aqueous. It contains a lot of water. Fat is lipophilic. It's not hydrophilic. It doesn't mix with water. Okay? And so as this fat globule passes down into the duodenum, okay, the same thing holds true. The fat tends to congeal, stay together, okay, separate from the intestinal fluid, the intestinal juice. Right? That means that most of the molecules of fat, most of the triglycerides are on the inside and they're not exposed to digestive enzymes. Only the very surface triglycerides are exposed.